Hello everyone and welcome to Leadcia. The first major distinction to be made in machine learning is the difference between supervised and unsupervised learning. To fully understand the difference, let's take an example. Suppose you have a new database of photos to categorize. You have a training set to train your model. In supervised learning, you are going to retrieve so-called annotated data from their output to train the model, i.e. you have already associated a target label or class to them and you want the algorithm to be able, once trained, to predict this target on new unannotated data. In our example, the input data would be images and the target, or target class would be the class of photos you want. In unsupervised learning, the input data is not annotated. How does this work? Well, the training algorithm in this case focuses on finding similarities and distinctions within the data on its own, and grouping together those that share common characteristics. In our example, similar photos would be automatically grouped together in the same category. Well, in case you have a problem where you can annotate precisely for each observation the target you want to output, you can use supervised learning. In case you are trying to better understand your dataset or to identify interesting behaviors, you can use unsupervised learning. There are in fact two other families of algorithms that we will not detail in this series of videos, but you are free to learn more about them. Semi-supervised learning, which takes as input some annotated data and others not. These are very interesting methods that take advantage of both worlds, supervised and unsupervised, but of course bring their lot of difficulties. In reinforcement learning, RL, agents are trained on a reward and punishment mechanism. The agent is rewarded for correct moves and punished for the wrong ones. In doing so, the agent tries to minimize wrong moves and maximize the right ones. Autonomous driving tasks where reinforcement learning could be applied include trajectory optimization, motion planning and dynamic trajectory. Regression or classification. Another distinction that will help in choosing a learning machine algorithm is the type of output that is expected from our program. Is it a continuous value, a number, or a discrete value, a category? The first case is called a regression, the second is called a classification. For example, if I want to determine the cost per click of a web ad, I perform a regression. If I want to determine if a picture is a cat or a dog, I perform a classification. To summarize, machine learning problems can be differentiated according to two criteria. Is the data you have available annotated or not? If so, you are dealing with a supervised learning problem. If not, you will be forced to use an unsupervised learning algorithm. What type of outcome do you want to predict? If it is a number, for example, the cost per click of an ad, it is a regression problem. If it's more of a discrete value, a category, e.g. the type animal in a photo, then it's a classification problem. Well, that was all for today. If you have any doubt, feel free to add your question in the comment section. Thank you.